Hello students, in this video we are going to discuss one of the most important topic for JEE Main and IIT JEE exam and also for NEET exam, which is LR circuit, inductor resistance circuit. There are two types of LR circuit. First one is the growth of current, second one is decay of current, that I will discuss in some other video. So let us proceed to discuss the growth of current in an LR circuit. Here in the graph you can see that the current is slowly growing with time. Let us see why this happens. Let us consider two circuits. In the first circuit, we have only a resistance connected to the battery, whereas in the second circuit, an inductor is connected to the resistance in series. What will be the effect of inductor in the second circuit? In the first circuit, as we only have a resistance, so what will happen that as soon as you close this switch at time t is equal to 0, the current in the circuit will begin to flow immediately, which can be shown in a graph like this. Look at the current time graph. Time is plotted on the x-axis, current on the y-axis. So at time t is equal to 0, as soon as we close the switch, the current immediately jumps to the value E by R. As per Ohm's law, the current in this circuit must be E by R, voltage by resistance. But how much time does it take? Immediately. As soon as you close the switch, the current in the resistor will begin to flow E by R, and after that it will remain constant. But if you connect an inductor with the resistance, then let us see what happens to the current. How does the current grow? We see this graph here. The current doesn't rise suddenly and become E by R, but it grows slowly. And then after a long time, it achieves the final value of E by R. So what we come to know from this by comparison of these two circuits is that if we have an inductor placed in our circuit, then this inductor will cause the current to grow slowly. It will not allow the current to suddenly rise and become E by R. So if the circuit contains only resistance, the current immediately rises to E by R. But in the presence of inductor, the current will slowly rise and may delay the growth of current. So who is delaying this growth of current? This inductor is causing the delay in the growth of current. And why does it do? Because of this reason. The inductor opposes the growth of current in order to oppose the growth of magnetic flux through itself. You must have already studied in the chapter of electromagnetic induction that an inductor or any inducting coil will oppose the growth of flux through itself. So what happened that as soon as the battery sends the current through the inductor, in these coils current begins to flow and a magnetic field is generated. That magnetic field would pass through these coils and create a magnetic flux. But in the beginning the current was 0, and now we are trying to increase the current to E by R. So as the current grows from 0 to E by R, this inductor flux would increase, but inductor will always oppose the growth of flux. So if the inductor opposes the growth of flux, therefore it will oppose the incoming current, and that is the reason why the current will not immediately become E by R. The current will slowly rise due to the opposition of the inductor, and ultimately after a long time the opposition of inductor is finished. That means after a long time the inductor no more opposes the current, and the current reaches its steady value, which is same as the current value obtained if there was no inductor connected in the circuit. So without the inductor, the current becomes E by R immediately. With the inductor, the current rises slowly and ultimately it becomes same E by R after long time. We will now do a detailed analysis. Let us suppose we have a LR circuit connected with a battery, DC battery. A resistor R and inductor L are connected in series to a battery of EMF E, the switch is closed at time t is equal to 0. This switch is initially open, so there is no current in the circuit. So when we close this switch at time t equal to 0, the battery will begin to send current into the circuit. So we have to derive an expression for the magnitude of current in this circuit as a function of time t. Let's begin. In order to find out the current in the circuit, we will be using the Kirchhoff's voltage law or the loop law. As you know, when we use the Kirchhoff's voltage law, either we can traverse the circuit in the clockwise direction or anti-clockwise direction. The best way is to move in the same direction of current. As the current in the circuit is going to travel clockwise, so we will also travel in clockwise manner only. What does the Kirchhoff's voltage law say? The Kirchhoff's voltage law KVL says that the sum of potential drops in a closed loop is 0. That means if you traverse the loop, then potential difference of battery plus potential difference of inductor plus potential difference of resistor, total should become 0. That means we can write down like this: delta V of the cell plus delta V of the resistor plus delta V of the inductor equal to 0. Let's begin. Now, while writing the Kirchhoff's voltage law, there are certain rules to be followed for the plus or minus sign that should come for this potential difference. When we are traversing this circuit in the clockwise manner, then we are moving in the battery from its negative terminal to the positive terminal. Therefore, what will happen that the potential will rise here. See, once again you see, we are traversing the circuit clockwise. So as you move clockwise and you pass through the battery, we are moving from the negative to positive terminal. So there is an increase of potential, rise of potential. So we write down here plus sign, plus E. Okay. Now, but as we move forward, as we move through the resistor, see, we move clockwise through the resistance. Then what happens that the potential difference across resistor is I into R. But why there is a minus sign here? Because the potential will decrease. You know, current is flowing in the rightward direction. We are traversing also in the rightward direction through the resistor. We know that current flows from higher potential towards lower potential. So therefore, the current, we are traveling along the current, the potential is actually decreasing because potential decreases in the direction of the current. Or we can say current flows from high potential towards low potential. So because we are moving from high to low potential, there is a decrease of the potential and therefore we put a minus sign here. For inductor, we know that as we move in the direction of the current, the potential difference of inductor is minus L di by dt. So we have put all the values here in this equation. So we get E minus IR minus L di by dt equal to 0. One important note I would like to say regarding the inductor. When you are traversing the circuit in the same direction of current and you are using the KVL, then you put minus L di by dt for the potential difference of inductor. But if you are traversing opposite to the direction of current, then here you should say plus L di by dt. So student, please remember this very important fact. Whenever you are solving an LR circuit, then if you traverse in the same direction of current, you must always take minus sign for L di by dt, which is the potential difference of the inductor. Let us proceed now to solve this equation. This is a differential equation, and differential equation has to be solved by integration method. So what we do, keep this E minus IR on one side and send the differential constant on the other side. L di by dt we send to the other side. Then we will rearrange our terms. Let this L, which is a constant value, send to the left side, 1 by L, and this dt you multiply to the other side, time here dt, and E minus IR you bring it below this di, so that now it is integrable. This step is called as separation of variables. In the chapter of solving differential equations of maths, we call it as separation of variables. See, there are two variables in this equation. One is the current I, which is varying with time, and second is the time t. So what we do, that time t we have brought on the left hand side of equation, and the current I, these two terms containing the current I, we have separated on the right side. So we have separated the variables here. This step is called as separation of variables. all the terms containing the one variable I is on the right side, and all the terms containing time t, the other variable, is on the left side. This L is a constant, so can be put any side. Now this differential equation is ready to be solved. Let us now put the integral symbol on both sides. 1 by L is a constant. So integration of dt is equal to integration of this term di upon e minus ir. Okay. Now we must put limits of integration here in order to proceed further. Students, you must remember that in physics we rarely have any type of indefinite integration. In physics we always have definite integration where limits must be put. So we put lower limit. At time t is equal to 0, in this circuit the current was 0, because at time t equal to 0 the switch was open, so there was no current in the circuit. So lower limit is the initial condition. At time t is equal to 0, the current was 0. Then after time t, let us say after t seconds of time, the current in the circuit becomes I. That means we are assuming that let the current is I after time t. Now we can proceed to perform this integration. Left hand side integration of dt would be t. Integration of dt is t, and we will show the limits, lower limit, upper limit 0 to t. And on right hand side, this integration would become logarithmic answer ln with natural logarithm of e minus ir. How this became, I will tell you. In our maths textbook you can check this formula, that integration of dx upon ax plus b, here a and b are constants, x is a variable, dx upon ax plus b integration is natural log of ax plus b divided by a, divided by the constant which is the coefficient of the variable x. So now can we rewrite this equation in this format? Can we compare both of these? Let's try. This integration over here, di upon e minus ir, I can write down as, this is I, okay, sorry for mistake, this is I, di upon this denominator, can I write down I, e minus ir can be written as minus ri plus e. The same thing denominator I have written here as minus ri plus e. Why? Because see, x is a variable, so I is a variable, a is a constant, minus r is a constant, b is a constant, e which is the EMF of the cell, that is also constant. So we can compare both of these. And let me make a correction here, that this here is actually we have di, okay, not dx, this is di. Now, so if you compare both the formulae, then we can clearly see the constant a is same as minus r, constant b is same as the constant e, and the variable x is I. So therefore, if this integral gives answer ln ax plus b, then this one should give us answer ln of minus ri plus e, and divide by what constant? The coefficient of the variable. So here variable is the current I, its coefficient is minus r, so divide by minus r. That's how we are getting this result of the integration. But now we have to substitute the limits, lower limit and upper limit, 0 to I. Let's proceed on the next sheet. So this was the expression that we obtained on the previous page, and we will now substitute the upper limit and lower limit. So first we have to substitute the upper limit here and minus the lower limit. So we'll get 1 by L into t minus 0 on left hand side. Right hand side, we have to substitute the value of I in place of I, and then the value of 0 in place of I, because I is the variable, so upper value and minus the lower value. So what do we get in the numerator? Natural log of, first of all, e minus ir by putting I in place of I, and minus, then you put 0 in place of I, so you'll get minus ln e, and divide by constant will remain as it is, divide by minus r. Furthermore, this numerator can be written as ln of e minus ir divided by e, because you know that log of a by b is log a minus log b. So this log of e minus ir minus log of e can be written as log e minus ir upon e using this formula. And this minus r I am multiplying to the left side, cross multiply, so minus rt by L is equal to this. Now how do we get rid of this logarithm here? Opposite of logarithm is exponential function. So taking exponentials on both sides, or we can say taking anti-log on both sides, we get e to the power. So left hand side we have minus RT by L. So taking exponential, that means e to the power minus RT by L. And when we take the e power of ln this, then ln gets cancelled and we get only this e minus IR by e. Now let us simplify this one. Here, you know, this small letter e, this means what? This is the Euler's number. Okay, also called as exponential. So e power minus RT by L is equal to, on the right hand side you see e upon e is equal to 1, and remaining is IR upon e. Simplification we have done. Then what we can do, that this IR by e you bring to left side and this exponential function take to right side. We will get this. Then we want to find out the current I. So multiply ER the other side. So we'll get current I is equal to E by R into 1 minus e power minus RT by L. So this is the final answer. This is the answer of this question. We have obtained the current, magnitude of current in the circuit as a function of time t. So the current varies with time t in this manner. If we plot the graph of this function, then we would be able to see that how the current is changing with time. We'll plot it in the next page. So here the graph. This function, this mathematical function 1 minus e power minus RT by L, this is mathematically plotted like this. Which physical interpretation here is that the current is slowly growing from 0 up till the maximum value, which is E by R, because of the presence of the inductor. Now let's proceed further. We can write down this E by R as the maximum current, because from the graph itself we can see that it is approaching toward the maximum value, which is E by R. So E by R can be written as I max. Okay. Furthermore, look at this power of E. It is minus RT by L. So this R from the numerator can be brought below the L in the denominator. We can write down like this: L by R minus T upon L by R. Now this ratio L by R has a significance. This ratio L by R is called as time constant, and it is represented by the letter tau, Greek letter tau. L by R is called as time constant. Why it is called a time constant? How it is related to time? Because this ratio L upon R, inductance by resistance, has the dimensions of time. That means the SI unit of L by R is seconds. Why is it so? Because for any exponential function, the power of the exponential function is always dimensionless. You can check this concept in the chapter of units and dimensions. It will say that the power of exponential function should always be dimensionless. So if you write down as e to the power minus t upon L by R, so if the numerator has the dimension of time, the denominator L by R must also have dimension of time, so that this ratio T upon L by R must be dimensionless. That is why L by R has the dimensions of time, and thus it is called as time constant. It is measured in seconds. So now this formula can be written in a more compact form. I is equal to I max into 1 minus e to the power minus t upon tau. Tau is the time constant. Let's learn some more. So what is time constant? Let us learn more detail about the time constant. What is time constant? See, for understanding the meaning of time constant, let us calculate the value of current after tau seconds. That means after one time constant amount of time. Or that means you have to substitute t is equal to tau seconds in the formula. So what was our formula? Here is the formula for calculating current after any time t. So we want to find out what is the value of current in the circuit after time t is equal to tau seconds. That means after one time constant. So here you substitute t is equal to tau. So we'll get I max into 1 minus e to the power minus tau by tau, which will become e power minus 1. Now what is the value of e power minus 1? This letter e, as I told, is called as Euler's number. It is an irrational number, same as pi. Like pi is an irrational number, cannot be represented as the ratio of two integers. Same way, Euler's number cannot be represented by ratio of two integers. Its value is something like this, which goes on. It doesn't end. It is a non-terminating and non-repeating irrational number. For practical purposes, we can take its approximate value as 2.7. Then, if you want to find the value of e power minus 1, then that means we have to take e power minus 1 means 1 upon e. That would be 1 upon 2.7, and with the help of a calculator, or we can calculate, otherwise the value will be 0.36. So we substitute here e power minus 1 is 0.36, or 367, something like that, so 0.37. So this subtraction 1 minus 0.37 would be equal to, I think here one place of decimal was missing, so its rounding off is 0.37. So 1 minus 0.37 is 0.63. So what we get at the end, that the current amount of current after tau seconds, after one time constant, is 0.63 times of maximum current, or it means 63%. 0.63 means 63 by 100, that is 63%. So 63% of the maximum value, maximum current. So now we can understand what is the meaning of time constant. Time constant is that much amount of time in which the current will reach 63% of maximum value. See the graph. The maximum current is E by R. 63% would be somewhere here, because 50% is half. The half height, this is 50%. So 63 is somewhat above 50%. So 63% of the maximum current is attained in how much time? That time taken is equal to 1 tau seconds, one time constant amount of time. So we can now write down the definition that one time constant is that much amount of time in which the current in the circuit grows to 63% of the maximum value. That is called as one time constant. This definition must be learned and memorized properly. Now, as we have understood that in one time constant the current rises to 63%, so what will happen after two time constants? What will be the current after two time constants? Will it be 2 times of 63%? That means 126%? Obviously no, because current cannot go beyond 100%. And from the graph also you can see that in two time constant, like somewhere here the second time constant, the corresponding value would be it will still be less than 100%, right? Somewhere here. So let's check it out. Let's calculate that what would be the value of the current after two time constants. So let us answer some basic questions, that what is the current after two time constants, what will be the current after three time constants, and so on, 4, 5, 6, and ultimately when will the current reach its maximum value of 100%. Let us solve all these questions and try to get the answer. First let us calculate the current after two time constants. For one time constant we already got the answer, it was 63% of maximum value. Let's do for two time constants. So for two time constant you have to substitute time t is equal to 2 tau. First write the formula that current at any time t is I max into 1 minus e power minus t by tau. Now you substitute the time t here as 2 tau. Then we'll get 1 minus e power minus 2. Once again, the value of e is approximately 2.7. You can do the square and take the reciprocal. You will get 0.135. E power minus 2, or 1 upon e square, is 0.135. So you subtract and you will get 0.865 times of maximum current. That means 86.5% of the maximum current. So in one time constant the current becomes 63%. After two time constant it becomes 86%. That means it is not the double of the 63%. Let us also calculate the current after three time constants. So you have to substitute time t is equal to 3 tau in the same formula. So write down the formula first of all, and then you substitute t is equal to 3 tau. Then you will get 1 minus e power minus 3. Once again, with the help of a calculator you can calculate what is e power minus 3. That is 0.049, and after subtracting you get 0.95, approximately 0.95 of I max. That means it is 95% of I max. So interesting thing to know that after one time constant, the current is 63% of maximum value. After two time constant, it is 86%. After three time constant, it is 95%. So here I have done one analysis which I want to show you. After one time constant, two time constant, three time constant, 4, 5, 6, 7, 8, I have calculated the values of percentages, and what we observe. After one time constant, current goes to 63% of maximum value. After two time constant, 86%. Three time constant, 95%. After four time constant, 98%. Then 99.3, 99.75, 99.99, 99. You see, still not reach 100%. A very interesting thing to note here in this data is that in the beginning it was growing very fast. 63 to 86, very big jump. 86 to 95 also a big jump. But as the time passes by, see, all these are equal time intervals. Even in equal time intervals, the amount of jump is not the same. Later, this increase in the percentage is very small. Very slow growth is taking place. You can see 99.33, 99.75, 99.99, 99.96. So that can be seen from this graph also, that in the beginning the current is growing very fast, but as the time progresses, the amount of growth in the current becomes slow. Very well. Same we can understand here also. See, after one time constant, the amount of current was 63% of maximum value. After two time constant, it was 86%. After three time constant, it was 95%. See, on the horizontal axis, the time gaps are equal. These time intervals are equal. But the amount of percentage jump is not equal. From one time constant to two time constant, the jump was, okay, start from 0. From 0 to one time constant, the jump was 63%. From 1 to 2 time constant, the jump was only 23%. Then from 2 to 3 time constant, the jump was only 9%. The next jump will be even smaller. That means as the time progresses by, the amount of growth in the current is actually decreasing. That is why this graph is in this shape. Finally, let us try to answer this question, that if the current is behaving like that, then how much time it should take to become maximum or to reach the 100% of the maximum value. So write down the formula first of all. Current growth formula is this. We want the current I to become equal to the maximum current. So we write down like this. I max is equal to I max 1 minus e power minus t by tau. Then this I max we bring to left side. I max upon I max is equal to this. This ratio is equal to 1. 1 is equal to 1 minus e power. Then this exponential function bring to left side. So right side you get 1 and minus 1, which is obviously 0. So we get e to the power minus t by tau equal to 0. So what should be the value of t upon tau? First let us do one thing. Here is a minus sign in the power. So can we bring it in the denominator? This same thing can be written as 1 divided by e power t by tau, and that is equal to 0. Now students, we know that 1 divided by infinity is 0. Because infinity is a very large number, so 1 divided by a very large number approaches towards 0. So therefore we can say that this e power t by tau must be equal to infinity. So let's write down that e to the power t by tau is infinity. Furthermore, we also know that e to the power infinity must be infinity. Why? Because the value of e is 2.7 approximately, and any number which is greater than 1 raised to the power infinity, that means multiplying that number with itself infinite number of times will give infinity. Definitely 2.7 into 2.7 into 2.7 into 2.7 into 2.7, you keep on doing infinite number of times, you will get infinity. So therefore we can say e power infinity must be equal to infinity. So from this, can we say that this power t by tau must be equal to infinity by comparison? So t by tau must be equal to infinity, and then cross multiply infinity multiplied by tau would be infinity. So therefore the time taken is infinite. This is the answer for this question, that how much time it will take for the current in the circuit to become maximum 100%. It will be infinite amount of time. So it takes very long time to achieve 100%. But it takes a few time constants only to achieve 99.9%. In one of the previous pages you saw that it took nearly 8 or 10 time constant to arrive at 99.9%. Now in my next video I will discuss many more numerical problems based on this concept. For now, this is the end of this video, and I thank all of you for watching my video till end. Please do comment, write down what you feel about this video, what more you want me to create more videos like this. I would definitely do that. And if you liked my video, please press the like button and please share with your friends, your classmates, your fellow students who are studying in coaching, so that they can also understand. And please subscribe, because I'm going to create more and more videos like this. Thank you. My name is Physics Guru. My website is youtube.com/thephysicsguru. Thank you all.